Thanks for tuning in to this weather briefing. This will be a briefing discussing the winter 2015 through 16 and a recap of El Nino. Okay, what did we expect with this year's El Nino? Well, we expected the jet stream to respond as shown in the red and more often than not cut across Southern California. So how does El Nino set up? Well, first the conditions are shown here, and at first it takes place in the ocean. That's the El Nino condition. The warm water comes from the western Pacific Ocean and then moves eastward as the trade winds are overwhelmed and the water is displaced from west to east, causing unusual warming of water in the eastern Pacific Ocean. Is El Nino gone? It's still around, as shown here. Here's one of the latest satellite imageries showing the warmth of El Nino. Though it's shrunk and continued to get smaller, there is still a considerable amount of warm water in that zone. Also notice most of the eastern Pacific is very warm. So do we blame on El Nino if we don't get the amount of rain or snow that we expected in any given winter? Well, we can't blame it on El Nino directly because El Nino was there and it was massive. In fact, it set records as shown below. The strongest instantaneous or 1 week average of 3.1 degrees Celsius or about 5.5 Fahrenheit. And it even tied the 3-month running mean set back in 97-98. We got to look more at the atmosphere if we're going to blame anything. Here are some of the numbers. Let's compare some of the past strong El Ninos. Pick your location that you're closest to, where records go back over 100 years, and you can see some big rainfall amounts occurred consistently in both of those strong El Nino years. And then you can see the numbers for this year. In the San Diego's case, it was about half as much, a quarter as much, when you look across Orange and Riverside County. Here are some of the precipitation amounts we've seen. I'm going to pick on Santa Ana Fire Station, where we have great records. That area has received 36 inches of rain in the past 5 years, but they are short, almost 40 inches of rain. That is about a 3-year deficit missing. You can also see in the center column there, for this particular winter, our locations that we monitor closely were anywhere from 33% of normal in Santa Ana to as much as 73% of normal in Idlewild. And speaking of Idlewild, here are some of the mountain locations, the specifics. And you can compare this year with a normal year. You can see we were below at all locations, including the deserts. And then compare to some of the very large numbers that occurred in the prior El Ninos. Do note that there is some missing data for the mountain locations. When did we see the atmospheric respond? Well, in early January, we saw a series of storms, almost like a train of storms coming across the Pacific. This is the classic El Nino signature when it comes to what the atmospheric conditions look like in response to those warm ocean waters. Again, keyword atmosphere. Most of the winter, however, looked more like this, and the extreme weather pattern we had in February, setting record warmth across our region, was the result of storms going across the Pacific as shown here, but completely missing us and going to the north. What does it look like for the entire water year since October 1st? You can see the region in Southern California, well, we're falling well short of precipitation even compared to a normal year. All areas are ranging from about 35% of normal to, at best, 75% of normal. However, in Northern California, the green areas were normal to above normal in many of the locations, especially in areas important for water supply, that is the mountains. Here's a zoomed up version of Southern California. You can see San Diego County did the best, and some of our mountain locations, as you saw in the prior numbers, were close to normal and in some cases a little bit above normal. How about temperature? Well, we have been talking about warm temperatures in the past couple years, and there's a reason for that. We've been breaking records. Well, this past winter was really no exception. Coastal areas and especially inland mountain areas ended up being several degrees above normal, widespread 2 to 4 degrees above normal as shown here in the orange. In particular, we had some very warm temperatures in the month of February, record warmth across our region. Records were set at our key climate locations as shown here on the right. Departure from normal for the past year? Well, 2014, 2015 were the hottest on record in California. The hottest on record. And this extended all across of California and really much of the West, including the mountain areas. There was an interesting record set in March 2016 across the whole United States. Every climate location, as shown on here, ended up reporting above normal temperatures for one particular month. That's the first time that's happened. Science has also shown some interesting issues in Greenland ongoing. Take a look at this example here. This shows some of the melting of the ice caps and the snow in Greenland prematurely. Now, El Nino comes in many shapes and sizes. Here's an article that talked about water supply, or in this case, a small country in the tropical Pacific that is drought-stricken to a severity where they're running out of water. So El Nino is not only an impact across California, it can be globally, and it's not always rain. It can be drought as well. So what happened this winter? Well, let's look at the past couple big strong El Ninos atmospherically. Basically, we saw a jet stream, a very strong, unusually strong, elongated Pacific jet stream pointed at California. Now, this year, we didn't quite see that same jet stream in the same place. While it was present and it was unusually strong, bringing significant storms north of Hawaii, it turned and split as it got to our region here, causing most of the storms to be in far northern California and the Pacific Northwest. Let's take a look at that actual jet stream. Those strong winds caused significant storm systems to persistently move across the central Pacific, and major swell occurred around and north of Hawaii. Over our region, we were split between the subtropical jet and that Pacific jet, leaving us often in a dry zone. Now, what was going on in the tropics? So if we're going to look at El Nino, which is a tropical condition of ocean temperatures, we need to look at what that tropical ocean condition is doing to drive our atmosphere. We saw less activity in the eastern Pacific when it came to thunderstorms and heavy rain development, which in turn can change our jet stream pattern. We saw most of that activity further to the west in the central Pacific, out near the date line as shown here. When we look at what is the atmosphere doing, high levels up where airplanes fly, we can see the zone where the water was very warm was very active. But we can also see during the course or the heart of the winter, that zone was not very active in the eastern Pacific. This may be one cause to why the jet stream did not respond and pull as far south persistently. Now we can also look in the middle of the atmosphere to see what was the prevailing motion of the air. For rain, we want rising motion. You can see over our region, prevailing sinking motion. Now this is not sinking from high pressure over the Four Corners region. That is a summertime warm season phenomena. This is sinking due to atmospheric and largely tropical conditions forcing it, as shown here. Look at all that rising motion over the Pacific Northwest. That was the result of a lot of rain. When we compare the instability zone with other years, you can see that in those years it was certainly centered more in the eastern Pacific. Take a look at the purple shaded area, compare it to 2016. What about if we look directly at where it rained hard and where it didn't in the tropics? Because El Nino is a tropical ocean condition that affects our atmosphere globally. and we need to focus on where that's occurring. You can see that the highest precipitation was along the equator and extending further east. Now, for 2016, again, it was focused in that western portion. Let's look at the wind differences that occurred again for 83 and 98, the two big El Niños. You can see in 2016 it was much further west and persistent further north than in 83-98, where it was taking a direct hit across central and southern California. How about moisture, the content, the water vapor in the atmosphere? We can take a look at that, and we don't really see any differences from one El Nino to the next, and we see the deep tropical moisture focused along that El Nino zone, as you would expect. In 2016, where the arrow was pointed, you do see that there was some persistent moisture plumes that were aimed at far northern California and the Pacific Northwest. Let's take a look at the sea surface temperature anomaly differences. Well, again, in 2016, it was focused a little bit further west in the Central Pacific. Look at 97, 98. It was really focused during the course of the winter months, more in the Eastern Pacific. That particular El Nino was very strong, though it did weaken faster than the current El Nino in 2016. It did reach a high peak early on in the winter. All right, so let's take a look at the improvement, or the good news. Here we see that the water supply was extremely low and much below historical values as of early December. And take a look at the right-hand side. Capacity of some of the major reservoirs went from 20 to 30%, all the way up to 80 to 90%. How is our local water supply doing? Well, as you can see here, because of the little rainfall we received, or much below normal in some cases, water supply locally has not improved. Diamond Valley Reservoir, which takes a lot of water from the Colorado River as well, that area remains near record low. How about across the state? How much water is available to filter down into our reservoirs? We can see the snowpack, which is already starting to melt, is down to about a 70 to 75% compared to where it should be. Now, when they did take the snowpack estimate on April 1st, many of the locations in the far northern Sierra Nevada were near 90%. Here's a visual of the difference. So from 2016 to 15, you can see the white covered area was much smaller of coverage back in 2015. That's when we saw record low supply. Also take a look at the greenness on this visible imagery. You can see it's greener in many places this year compared to last. San Diego County local water supply. Well, here are the numbers. The capacity is shown on the left, and it's about 40% of capacity, which was what it was about this time last year. Note here where San Diego County gets a lot of its water from, and also coming in from the new desalination plant. But the good news is there has been an increase in local water supply thanks to some of the recent rains. Now, across the entire west of the Colorado River Valley, there's also good news that near normal precipitation occurred in the headwaters of that region. And then you can see that in the Sierra Nevada, roughly around 80% of the precipitation, including rain and snow, has helped bring those reservoirs up to significant levels. Where did the storms and rain, and when did they occur? Well, this here is an indicator for the Sierra Nevada, and you can see we had some significant precipitation in January into February, and then also the month of March, where the precipitation index for 2016 ended up being above normal. And of course, we still can get precipitation in April and May. Here's another look at it. You can see that in February, precipitation was pretty much absent in the mountains of California. And when you compare it to normal, not even close. But there were 3 months where we did well. Here's a look for far northern California. And when we had those significant precipitation events, specifically in January and March, we made big grounds on the water supply, but unfortunately we had the February that was very dry. Let's take a look at one of those events. In late February to early March, this was the amount of rain that occurred. Some places in the northern Sierra Nevada, where those big reservoirs are, received up to 20 inches of rain. The drought monitor. We all look at the drought monitor and been monitoring it now for the past several years as it's been focused on California for the worst drought conditions. Good news is we made improvement because of the rain and water supply increase in the northern portions of California and parts of the Pacific Northwest as well. But we still have a long ways to go, especially in the heart of California into Southern California. What about our current El Nino? Where is it going? Well, it is rapidly decreasing as shown here on the right, and it's still considered a strong El Nino, but it's rapidly decreasing and will be replaced by cooler waters that are sitting underneath it. Here's an image of that El Nino that is continuing, and over that area in the rectangle is the zone that we focus on. What's the spring outlook? Well, this gets updated every month, and the latest outlook calls for wetter conditions expected through June for parts of California, but not really all of California, and warmer conditions also expected in parts of California. Now, for us in Southern California, there's very little indication as we expect to be in between systems, and the good news on that part is not extreme occurrences of heat or rain or dryness expected. Here's a quick look at our webpage where you can find the latest weather information for watches, warning, advisories, and also point and click on the map to get your forecast. Here are some weather links that you can follow. Of interest will be the digital forecasts and on your phone, the mobile, or an advanced level previewweather.gov. Of course, we're on Facebook and Twitter, and this YouTube is available to share to everyone on YouTube. Thanks for tuning in.